Hey everyone! In this video, we're going to be looking at how to use the product rule to find the derivative of a function. So I have an example here. It's y is equal to 1/2 x squared minus 2x times 1 plus 2 times e to the x. So if I want to find the derivative of this function, I'm going to need to use the product rule. And let's just remind ourselves of what that is first. So if I have a function, let's call it capital F of x, if this function can be written as the product of two other functions, our product rule says that the derivative, capital F prime of x, is equal to the first times the derivative of the second plus the derivative of the first times the second. And taking a look at the equation we're given, we have these two expressions that are separated in groups of parentheses. So what we can do is let's let f of x equal that first expression. So f of x is going to equal 1/2 x squared minus 2x. And then let's do the same thing. Let's let g of x be that second expression. So 1 plus 2 e to the x. So now, kind of separated out, these are easy enough to find the derivative of. We have any number of rules that we can use. For example, in f of x, we can use the power rule, and we're also going to be using the difference rule to find the derivative here. So f prime of x. For the first term, we're going to have our 1/2, that coefficient, and then the derivative of x squared is 2x. And our second term, the derivative of 2x is just 2. And simplifying that, so f prime of x, we end up with 1/2 times 2, so we just get x minus 2. Now let's do the derivative of g of x right away. So g prime of x, again we can separate it using our sum rule for derivatives. The derivative of a constant is just 0. And then for e to the x power, the derivative of e to the x is just e to the x. So this one stays the same. So our derivative g prime of x is equal to 2 e to the x. All right, so now let's go back to our original equation and let's find the derivative. So y prime, we already defined everything, and now we just need to use our product rule to find the derivative. So we have the first, so this original one, which we said was f of x, this one stays the same, times the derivative of the second, so g prime of x is 2 e to the x, plus now the derivative of the first, so f prime of x we found to be x minus 2, and then we'll multiply this by the original g of x. All right, so now let's do some simplifying. I think what I'm going to do first is I'm going to leave these first ones as is for now. And then in my second grouping here, I'm going to distribute the x minus 2. So x minus 2 times 1, and then we also have 2 e to the x times x minus 2. Now, taking a look, I have two terms that both have a 2 times e to the x in them. My first term here, and then also this last term. They both have that 2 e to the x. So why don't we factor that out? And if we do that, what we're left with, we have the 1/2 x squared minus 2x, and then we have the x minus 2 from that second term, and this is all being multiplied by 2 e to the x now. And we still have our plus x minus 2 left over. Okay, in the parentheses up front, we have some like terms you can combine. So we're going to end up with 1/2 x squared minus x minus 2, and this is still being multiplied by 2 e to the x. And then I think the last thing, let's take the 2 from in front of 2 e to the x, and let's distribute that through this set of parentheses. So for my final answer, I'm going to have 1/2 times 2 is x squared minus 2x minus 4. That's all being multiplied by e to the x. And we still have our plus x minus 2 at the end. So that seems pretty clean. We're simplified as much as I want. And it's in a form that would be easy to use. So that's how you use the product rule to find the derivative of a function that's written in the form of a product of two other functions.